They were frustrating. It was like working with 3-year-olds sometimes, because they had these emotional things and they had to be entertained, um, and they misbehaved. They learn. One time, after a while, after the aquarium had been established, we'd be diving, and eventually the dolphins realized that the tube going from our mouthpiece to our tank had air bubbles in it. And so they would pull the mouthpiece out of our mouths and watch the air bubbles float up. They thought that was so fun. Of course, we couldn't breathe. So that for them was play. Another interesting, I want to talk about something that happened to me, is their amazing ability to echolocate, and it helps us to see how they communicate. I'm just trying. Dog clicker training development from dolphin training. Yes, they actually use dog clickers for more for like sea lions. They will do it for dolphins, but dolphins oftentimes they'll use these dog whistles more because they can hear it better underwater. That sound travels underwater better. So oftentimes in more professional performances where the dolphins have to go down under the water, the trainers will have these whistles that they'll blow, kind of like a dog whistle. So dolphins, let's talk about dolphins and their ability to echolocate. And thank you, Your Majesty. Can I call you Your Majesty also? About the echolocation. Dolphins have several structures to echolocate, and this is how they can identify what's around them. They are able to send out hundreds of clicks, 800 clicks, I think, per second. And as they're sending them out, they send them out in groups so that they bounce off of an object and come back intermittently in between the pattern that they're sending out. Now, to echolocate, a dolphin has several different things. They have their blowhole that they have to push air through. They have nasal plugs. A nasal plug is a muscular plug. If you've ever blown up a balloon and didn't tie off the top, but you fill it up with air and you just kind of pull it and make that fun, annoying, squealy sound that your parents tell you to stop doing, that's kind of what a nasal plug does. And that's how a dolphin is able to control the squeaks and the whistles using their nasal plug. The air sacs are muscular, so they can control how they force how much air is out of their blowhole. And then they have a melon. And the melon, although it may look like it's a forehead, it's really made up of fatty tissue, and it behaves like a lens so that they can focus their outgoing clicks, depending on where they're aiming it at. When the clicks come back, they receive them with their lower jaw. The bone of their lower jaw, it actually extends up into their inner ear, and that's a unique design. No other animal that we know of has an inner ear bone, lower jaw connection like that. Now, they basically hear with their lower jaw. What's interesting about that is we kind of do too. And have you ever heard a recording of your voice before? For the first time you hear it and you'll say, "That's not what I sound like." And everybody else around you will say, "Yeah, that's what you sound like." Because the difference is this. People around you are used to hearing your voice as it sounds traveling through air. It travels through air, goes to their ear, and they hear it. When it's coming out of a recording device, it's traveling through the air, and they hear it. So it sounds the same. When we speak, our voice is coming out of our mouths through the air to our ears, but our vocal cords are also vibrating, and that vibrations travel faster in solids than they do in gases, which is the air. And so that gets up through our neck, through our jaw, up to our ear, not as rapidly or as well as a dolphin, but it affects how we hear our voice. So we hear our own voice differently. It sounds differently than if we were to hear it recorded. So we kind of do receive sounds with our jaw a little bit. But dolphins are super powers at doing that because their lower jaw extends up into their inner ear. And so one thing we know with dolphins is they're able to identify a lot of stuff with what's going around them. And they're also able to process. Now imagine a pod of dolphins. Very rarely do dolphins live by themselves. And they're traveling and they're sending out echolocation after echolocation after echolocation, and they receive back their own. They don't receive back the guy next to them or the one over there. They're able to identify their own echolocations because they are so keen keen at sending them out and receiving. So their superpower is echolocation. And what echolocation tells them is what's around them. You know, it helps. It's a survival requirement. It helps them identify what's around them, so they don't bump into things, don't bump into each other, and what things are made of. And they do this specifically to help them find food. So this is a survival characteristic. They have to be able to echolocate to find their food. And one unique thing about echolocation is they have to be able to eat and breathe at the same time. They have to echolocate, which is a type of breathing. That means air has to be moving out of their lungs at the same time they're eating. Can humans do that? If we eat and breathe at the same time, what comes out our nose, right? Well, it's because the tubes for breathing and eating are shared in our bodies, but they have a separate breathing pathway from eating and breathing, and that is unique to them. So all of these parts that a dolphin needs, all of these components are necessary for a dolphin to be able to echolocate. If they can't echolocate, then they cannot survive. So this is a requirement. This is called a complex system, organ system. How could we explain this to have evolved? Because dolphins are supposed to have evolved from non-echolocating organisms. So we're talking about a blowhole, separate breathing and eating pathways, an air sac, nasal plugs, an inner ear that is connected to a lower jaw that extends up into it, and a melon. And all of these are large items in an organism. And so they couldn't just suddenly appear. You can't explain that with mutation, positive mutation. We've never seen the very rare positive mutations we've seen at all, which are very, very rare, are nothing like this. In fact, most mutations are deadly, and some are neither harmful or helpful. So they have to be positive mutations to all of a sudden appear, but that can never happen. So what scientists who believe in evolution will tell you is, well, all of these parts were used for other purposes and then came together to form the echolocative ability that dolphins have. I find that hard to believe because we're talking about a lot of big parts that all had to have some other purpose and then instantly were not needed for all those other purposes so that they could come together and work as a unit, as a complex unit of organ system all at one time. So this new dolphin who was born who had echolocative ability that its parents did not. That is, we've never seen anything like that happen in nature, never been observed. It's extremely far-fetched even to suggest that, and yet that's what they're going with right now. So to me, dolphin echolocation is a huge testimony to creation. And these guys were created specifically for the environment in which they're living. I firmly believe that. This is something that creationists will call irreducible complexity. And I don't know if you've heard the term irreducible complexity, but it refers to things like this. Whenever we see an organ or an organ system, like echolocation system, that is complex and cannot be reduced, that's what the irreducible part comes from. So let's say we remove the melon. We reduced it by one piece. Or we remove the nasal plugs. This organism doesn't have nasal plugs. We've reduced that system a little bit. Now that complexity cannot work, right? The system is broken. And so this dolphin would not be able to echolocate, would not be able to get its food. And so this is irreducible complexity. It's a complexity that cannot be reduced. And that, to me, is a testimony. And no, dolphins don't have really a smell. Someone asked if they smell. They don't. Their nose is their blowhole. Their nostrils are where their blowhole is. And so they breathe through their, right where the arrow is pointing. And so they don't really have, they can smell, but not the same way that we can. Their receptors are not as keen because they don't need that. Their echolocation gives them much more information than their ability to smell. Now, one thing that's really cool about what echolocation can tell them is it can tell them what things are made of. We've done research with dolphins before where we've been able to show them two balls that are the same size, the same color, one made out of wood and one made out of plastic. And there's no way to identify which is made out of which if they're not able to touch it or play with it. And so we trained them to identify the wood ball based on its echo. We'll show them the balls, ask them to identify the wood one, We'll mix them up again. We'll show them the balls again, ask them to identify it. About 98% of the time, the dolphins will identify the wood because they can tell by the sound of the echo coming back. And this is something, there's what I call a very lame lab in your in this module, where you get to open a can of soda pop, and that's really about it. And I'm changing that for the next